Hi everyone, this is a video that many of you have been waiting for. I'm going to show you how to build a full-stack chat application that runs on your own website using the new DeepSeek-r1 model. We'll have a look at the microservice architecture that we are going to use to build the application, what technologies we combine, and how Docker helps with easy deployment. There's a lot going on with multiple tools involved. I won't cover every single detail, just a high-level overview. Otherwise, it might be too much for some of you and the video would end up being 4 hours long or so. Before we begin, projects like this take a lot of effort for me, in this case around 20 hours and also some money due to server costs, but they don't get as many views as the typical Model XYZ shocks the entire industry type content. So to make these in-depth tutorials worthwhile, I'd really appreciate your support. If you'd like to help out, you can find my links to my Udemy courses in the description, plus a link to DigitalOcean where you can use a promo code to get up to $200 for free in credit. Thank you very much for your support. Now let's talk about the microservice architecture and the technologies that we'll use. We have Postgres as our database to store conversations. FastAPI and LangGraph will handle the backend logic for the chatbot. We're gonna use Ollama to run DeepSeek-r1 so it can generate responses. Our front-end application is built with Angular for a modern single-page application experience, and we use Nginx as a reverse proxy to route all the incoming requests. So here's the big picture how it works. When a user opens the web application in their browser, it goes through Nginx to load the Angular frontend. Whenever they type a message, the frontend calls the FastAPI backend, which then communicates with Ollama to run the DeepSeek-r1 model. Ollama sends back the response to the backend, and then the backend returns that to the frontend, where the user can see the chatbot's reply. All of these services run inside Docker containers, managed by Docker Compose, which makes everything much simpler to deploy. We have containers for Nginx, the frontend and the backend, Postgres and Ollama, along with volumes storing database data and the model files. When we deploy the application, we want to secure the website via HTTPS, so we use Certbot to get SSL certificates and place them in the Nginx container. This way we can host a fully secure chat application without much hassle. I will show you how to do that now in detail. Okay, I'm now in VS Code, and here you can see all the folders and files that we need to deploy the full stack application. If you want to get the files too and deploy it on your own website, then please go to the link in the description and clone the repository yourself. So here you can see 2 folders, the Angular frontend, which contains the Angular application. Then we've got the FastAPI backend with a very simple main.py. We've got an Nginx folder, which contains default.conf, and this is where we set the routing for our application because we don't want to access a website with the port at the end, but we want to access it with routes. We also got some helper scripts like the deploy.sh or the setupcerts.sh, where, for example, we download the certificates and put it in the correct folder. And at the end, we of course have the Docker Compose YAML file. Here you can see that is the file which builds and runs the front end, the back end, our Postgres for storing the conversations, and of course the Ollama container and also the Nginx container. So we've got a lot of stuff going on, but at the end, all of that will make sense. So this is how we start our service, and we're first gonna start with the backend where the actual LLM-based logic happens. To run a LangGraph application with Ollama, we have to install the LangGraph Ollama package, and from there we have to import the chat Ollama class. With that, we instantiate this class with the desired model, which we have to download also inside the Ollama container, and we have to pass the base URL here. And we set this environment variable here in our Docker Compose YAML. Here you can see it. That's the backend service, and here is the Ollama URL. So this is the name of the service, Ollama, and this will be started after the Ollama service is running. So let's go back here. So that's the setup of the model, and then we're gonna use the model inside a very simple graph. We use the built-in messenger state class from LangGraph, and this class makes it very easy to build chat applications where we always add new messages. It uses under the hood a so-called reducer function, and it always adds the returned value of a node and adds that to the state. So it's very convenient to use. So what we have to do is that we extract the messages key and pass the complete messages list to the model. This will return a response. What is special in the response of DeepSeek-r1 is that it wraps the thinking tokens inside some special thinking tag. And this is where we're gonna use the remove think tokens function, which uses a regular expression. I'm gonna show you that, how that looks like. So we're gonna pass that thinking pattern to that function, and this will remove everything inside this thinking text. So if you're interested in that, you can also disable that by setting the environment variable. So where is it here? If you set that to false, then it won't be removed. At the end, we return a dictionary with the key messages and the response, and this will under the hood add that to the list of messages because it uses a reducer function. Like I said, this happens under the hood, but it makes it very easy to set this up. Then we're gonna use state graph where we pass in our state object to create our workflow. We add this agent node, which uses the call model node function. And then we also set the entry point, which is agent. So nothing else is going on. We only call the model and update the messages state. Nothing else is going on here. We could make that, of course, more difficult, but I think for this example where it's all about deployment, this is sufficient. We're also going to make use of LangGraph's persistent mechanism called checkpointers. You can think of a checkpointer like a user session. So when you open the chat window, then you create a new session with an individual ID. And if you close it, then this session is gone. We could use an in-memory checkpointer, but if you stop the application and restart it, then all of the information is gone. And normally you want to save something like chats in a database, and we're gonna use Postgres for that. So to do that, we're gonna set up our async Postgres saver, where we first gonna create our connection pool to that, and then we're gonna run the setup function of the checkpointer to make the checkpointer work. At the end, we have to pass the checkpointer to the compile method of our graph. So this will now create our compiled graph, and now we can use our graph. I will save that in the application state. So this is a lifespan method of the FastAPI application, which only runs when the UBICon server starts. So it only runs once, and it gets saved in the state object of that FastAPI application. So we can access it by accessing the state object of FastAPI. So that's our graph and the setup of our checkpointer. But how does the FastAPI application actually look like? So we're first gonna create our app instance, and now we're gonna create our endpoint. So we got a checkpoint ID endpoint, and what happens here is that we're gonna make a GET request to that endpoint, and we get a new UUID, and this is what we're gonna use as our thread ID for our checkpointer. And this is the key part of our application, the chat endpoint. So we got a special request object, which is chat request, where we want to pass a thread ID and the new message. So what we're gonna do is that we first gonna check if the message is empty. If that's the case, we want to raise an HTTP exception. Otherwise, we want to create this human message object. This makes it easier for LangGraph to work with. We're gonna pass the user message to the aInvoke method of our graph object. Like I said, we stored that initially in the state object of FastAPI. So we're gonna access it like this, app.state, and this has the graph object, and this has got the aInvoke method. We pass this messages key with a new message, and we also pass this config object. So this makes use of a dictionary with a key configurable, and here we use another dictionary with thread ID. This way we're gonna use our checkpointer correctly. Now we use the aInvoke method to make a request to the Ollama server, which under the hood runs the model. This will return the response from the model. We save that in the output variable, and we're gonna provide some checks. This is always beneficial when you create larger applications. So we're gonna check if we actually got a response, and if that's not the case, we want to raise an HTTP exception. And if we get this, then we want to extract the latest message of the state object. So like I said, the reducer function of LangGraph always appends the latest message here, and this is the newest AI message. This is what we want to return to the user at the end. I think it makes sense to show you next how the frontend interacts with the API. So I know most of you are backend devs or data science guys, so we only cover the very basics, the interaction with the API, but not the complete user interface. So let's open the Angular frontend folder. Inside there you will find an src file or folder, then the app folder, and here is the interesting part of the application. So you can see some HTML, some CSS files, and the interesting part is first the chat.service.ts file. So that's a TypeScript file responsible for making the request to our endpoint. So you can see this is the base URL that so you can see that we've got two functions, get checkpoint ID, and here you can see this is the route that you also know from FastAPI /checkpoint ID. This is how we get a new checkpoint ID. And then we've got another function called send message. Here we pass a thread ID as argument and also the user message. This is what we send to the chat endpoint. So this is how we interact with the backend, and this is called from inside the app component. Here you can see that we inject the service, and here you can see this chat service makes the request to the endpoint, and then we're gonna save that in the application state or in the component state. And here you can see that is the send message logic, which makes use of the chat service. So this is how Angular handles all of that under the hood. Okay, so that's now the front end to backend interaction, but let's also check out the Ollama part. We don't have to do a lot to actually make that work, but we have to create this container image, and we have to provide some environment variables. We first want to set the gin mode to release, which actually under the hood only makes the web server which runs Ollama to run in production mode. This is better for performance, and we also want to set Ollama keep alive to -1. This means that the server will cache the model and not load it on every request, because this would make the application very, very slow. We're also gonna save our model in a volume, which means that if we stop the container image and start it again, then we don't have to download the model again and again. So if we download it once, then we can stop the server or stop the container, start it again, and we have the model available. Okay, so last part is the Nginx server. So if you have a look at that, then you can see the following. I'm gonna show you that here. It's a little bit easier without these certificates. So this is an Nginx configuration, and Nginx acts as a reverse proxy. So this forwards the client request to different backend services. So first we've got the root route. This is where our front end is running on port 80. Then we've got the /API route, and this is where our backend, so the FastAPI service, is running. Then we also got Ollama, and this routes to Ollama, which is running on port 11435. Okay, let's now do the deployment steps together. So to run a chatbot on your own website, you first need to own an own domain, and you also need an own web server where the application is running. You can get multiple hundreds or even thousands of tutorials how to get your own website. I would not recommend that you use uniteddomains.de because this is a German website, but you have to buy your own website. For me, it costs, I think, $20 per year. So I think this is quite a cheap investment. So like $2 or €2 per month. Most domains already offer some kind of name server for you, but you want a custom name server. So if you have a different provider for your website, then you should find something similar like this. So I had to enter for my own web server an S1 DigitalOcean.com for the name server 2 and for the name server 3. So this is what I had to enter, and then I had to save it. Now I'm gonna use my custom name server for my website. For your custom server, I recommend DigitalOcean. The service is quite cheap, it's customizable, and I'm quite satisfied with it since multiple years. I think I use it around about 10 years for multiple projects. So you have to sign up with Google, and very important, if you want to use it, then you can use my promotion code, which gives you $200 in credit for free. So after registering, then you have to create a new project. You can click here on creating a new project. I already created one, and this is how it looks like. Inside your project, you can create multiple resources. And the first one is that you have to connect, or the first task is that you have to connect the server to your website. So you have to add a domain or DNS. As you can see, I already got the domain, and now we have to configure it. Just click on that, and then you can see multiple entries here. We've got this NS, so namespace entry, which directs to ns.digitalocean.com. So as you can see, these three entries here match exactly the entries that I had to put in here on my domain for the nameserver 1, nameserver 2, and nameserver 3. So these have to match, that you actually connect the server What you also have to do is to create an A-type record. This A-type record has to direct to the IP address of your server. So currently there is an old one. I'm just going to show you how you can change that in a few seconds. So currently we leave it like this, but remember we have to provide 3 NS records and 1 A record. This can be forgotten because this was something I did for connecting me to OpenAI, but you don't have to do that. So next step is that after setting up the domain, that we create a new droplet. So droplet is the DigitalOcean name for a new server. Here you can now select the region. I would assume that you can find the closest to your location. I use Frankfurt in this case, and now we can pick an image. I use an Ubuntu image, and here you can find the images in different sizes. So I experimented a bit, and I want to run the 7 billion parameter model. So I had to use this 8 GB server. It costs quite a lot, like $50 a month, but yeah, that's the price you have to pay when you want to run an LLM locally on a server. So if you only want to run the 1 billion parameter model, I think you could also get away with paying $8 per month. So I will pick that. And the next step is that we create new SSH keys. So we need this SSH key, so we get a private key and a public key to connect with that key to our server. So we have to provide the SSH key content, and to do that, we could run this in a terminal, or you can also download a tool called PuttyGen. So this is the website puttygen.com, and yeah, it has a lot of ads, but it's free and easy to use. So I'm just gonna show you how that works. So let's open PuttyGen. So after installing it, this is the user interface of it, and now you can just click on generate. Then you have to move your mouse a bit, and you can see this works quite fast. And now we've got this public key. So we have to copy that key and now paste it here. Just paste it, give it a name. I just call it demo application, and then I'm gonna save that. So that's the public key. Now we have to download the private key. Very important, don't just close this. So we have to save the private key. So we don't have to set a password for it, but make sure that you download it and store it on a safe place. So I just call it like this, save it, and now it's on my desktop, and I can use that to connect to the server. The next tool that we need is an SSH client. I always use Putty. It's also very easy to use. It's free. And so yeah, to download it, just go to putty.org and then click on download Putty. Then after installing it, open Putty. And now we could enter our host name or IP address here. So, but to actually be able to do that, we first have to create our droplet. So let's scroll down. Here you can see nothing else to do. Just click on create droplet, and this way take a few minutes now. Okay, after waiting a few minutes, we can see that everything worked. So this is our droplet, and very important part here, this is the IP address of our server. So we have to press copy, and then we have to connect that server to our domain. So again, click on your domain here, and then we have to change that. So we have to edit that record, and we have to set the new IP, so the correct IP for our service. Otherwise, we cannot connect our website to our server. Okay, now we also gonna copy that again, and now we go to Putty, and we're gonna first save a new entry here. So we're gonna call that, let's say, demo application. Now we're gonna save that, and what we also have to do is here in connection, we have to go to SSH, open that again, go to auth, and here we have to set the private key for authentication. So this is where I saved it. Now I can click, we're gonna save that again before that, and then click on open. And now we can see Putty security alert. We can accept it, and we only have a root user available right now. So we are now logged in as root. You normally would create some other users, but in this case we're just gonna use root. Next step is that we gonna install some packages. So we're gonna run apt-get install and also update. So we all got the newest packages here, And yeah, it was quite fast, so it's already up to date. And now we can download or clone the repository that I provided for you. So that's the DeepSeek chatbot. If you run ls-l, we can see that here it is. We're gonna cd inside that folder. And here you can now see this is exactly the same that you saw before. Okay, so first step is that we set up the certificates. So you can see this is the setup certs.sh file. So if you have a look at this in VS Code. So what's happening here is that we gonna install some packages and we're gonna install snapd, and after that we're gonna use snapd to download certbot, and certbot will create certificates for us. So we have to use that in combination with Nginx. So to make that work, we will run sh and then set up certs.sh. This will now download all of the required packages. It does not take too long. Okay, now we can get our certificates. So we only want these certificates here. Okay, now we're good to go, and we can run certbot cert only Nginx to get the certificates just for Nginx. And as you can see, when we run it, we run into an error. So we have to install apt-get install Nginx. So we have to download it. This will also start the service locally. Then we can run that command again. So certbot cert only Nginx. And now we can see that this works. So we have to now enter our email address. So we want, for me, I want codingcrashcourse.com. And now we have to enter an email address. So I will enter my personal email address for that. And now we, of course, have to agree everything. Please enter the domain names. So again, codingcrashcourse.com. And now everything should normally work if we connected the server correct to our domain. So it works. We can see that now the keys are saved at coding-crashcourse.com. So here is the private key and also the full chain, so our certificate chain that we need. Okay, next step is to stop the Nginx service, and we have to run systemctl stop Nginx because we want to run our own Nginx server in the container, of course. So now we stopped it, and we can check that again. If we run status, we can now see it's enabled. We can also disable it like this, disable Nginx, disable, a little typo here. And now if we have a look at the status, we can see that it's disabled. Okay, now we got our certificates and we can use the deploy.sh file to make everything work. So we have to enter the domain here, and this will update the Nginx conf production file that you've got in your directory. So you don't have to edit that yourself. So just run sh and then deploy -sh. So here is the domain. We're gonna enter the domain codingcrashcourse.com, and we run into another error because Docker was not found. So we first have to download Docker. So you can find the link to the installation in the description. So here it is. Just copy the commands. That should work out of the box, but of course it also takes some seconds to download everything. Just type yes every time you ask for something. And now we've got that. Now we can install the latest version of Docker and Docker Compose. Install that again, click yes. And now we can see that the installation seems to work. And now we can run sh-deploy.sh again. Let's try it again, codingcrashcourse.com. Now we can see everything seems to work. We are downloading the correct images. So this may take a few minutes because it's actually quite large what we download here. So take your coffee, take a break, and then we are good to go in a few minutes. Okay, if everything worked as expected, then you will see everything here is green. We can run Docker PS. Here you can see that's the services that we are running. But now one step is still missing. We don't have a model yet. We only got Ollama running, but the model is not there yet. To download the model, I provided you this download.sh convenience script, and what's happening here is that you will be asked what model you want to download, and then we're gonna use exec. So we're gonna go into the Ollama container and run the Ollama CLI, because outside the container we don't have the Ollama CLI, and then we pull the model with the name we provided here as input. So I'm gonna run that sh and then download.sh. So we want to run or download DeepSeek-r1, and we want to get the 7 billion parameter model. So now the download is running. As you can see, this is also quite large, but actually the download is also very, very fast. But again, I think we have to wait a few minutes before we can actually run our application. Okay, so the download was successful, and if everything worked, then you can go to your website. As you can see, I'm now on coding-crashkurse.com, and we can see we are on HTTPS, so the certificates work. We can open the chat window, which will make a request to the backend to create a new thread ID, and then we can ask or type something like, hello, how are you? But keep in mind, this is a reasoning model. So reasoning models are slower than normal chat models. So you have to wait a little bit for the response. And also first time we will have to load the model. If you want a faster response, then you can easily switch from DeepSeek-r1 to, let's say, Ollama 3.1. So that's the answer. As you can see, the thinking tokens were removed. Hello, I'm just a virtual assistant. I don't have feelings, but I'm here and ready to help. How are you doing today? Yeah, the application works. It's running on our own website with our own server, and I think this can be quite beneficial to you. If you liked that video, then please leave me a like and also subscribe to my channel. Thank you very much for watching. See you in the next video. Bye bye.